So what I have is that there's blue colored pencil and there's just a regular pencil. So the regular pencil is the students' work before I intervened or anything like that. The blue is where I tried to help them, show them what strategy they could have used or what I was looking for. So the first time they went through it, I just let them do what I felt or let them figure it out on their own. And then later on, we worked on it afterwards. So we looked at whether or not they met the benchmark, and we looked at the X's are obviously the ones that didn't figure it out, and the C's at the top indicate that they were able to solve the problem without any help from the teacher.
So the benchmarks you're looking at this is a 4-point question or 2 or 3?
It's a 2-point question, I believe. I don't have the rubric with me.
So you did the blue.
So what are you looking for as a benchmark?
Just to be able to answer the question and solve the problem correctly.
So if they just get the answer, the work is just going to help you figure out what they were thinking if they got it wrong. But if they got the answer right, then you're not concerned about the...
Well, they should have been able to show some work to begin with to indicate that they understood the problem. Basically what I was looking for was just pictures, numbers, and words. What would they come up with?
But after you had already worked with them, that's what you're looking for?
Yeah, well, before, what I'm looking for is what did we do at the beginning? So the pencil right here, the pencil markings right here, the regular pencil markings is what they did. This is the work they did. The blue is what we did afterwards, and you'll see the similarities between all of them in blue color pencil.
If, for example, just to clarify, if this one has a lot of blue, does that mean they didn't do much?
Yeah,
to begin
exactly.
with? Okay, all right.
So you can look through it. If there's not very many pencil marks, then you know that that's all their work. So you can look and see what they did prior to the blue marks that we did.
I'm sorry, I must be being thick-headed here. So the blues, then you called them over and you worked individually?
No, we were as a class.
Or then you did it as a class, and then they went back. And after you did your exemplar on the board, then they went back and looked at their work. And so we're looking...
Well, you're just looking to see, they're not figuring out
how much they've
anything.
improved?
I don't know, because I know Freddie showed me, just said, show us what you did today. So this is just an example of how I collected the data, and then what the next step was, and then you can see the student work that we did today.
You already have worked with them, so maybe what we could do is figure out who still needs that extra help. And we're kind of... That makes sense.
And the reason why we're using looking at your work, showing is because you were recording.
Yeah.
That the lesson recorded, so we thought it'd be good to follow through and see how, just for closure and see how things went.
Okay.
That's the whole reason for
Let's
that.
do that.
So Peter will do the next PLC, we'll expect to do the work.
So we could probably still think of it as
So here's
benchmark proficient and not?
I think so. I think we should still number.
Because we're looking for
them
those
and see
knots, right?
So
The ones that-
here's I would say this is benchmark here is what I was looking for. So you can see that we indicated as correct right there. And you can see there's not much pencil blue markings right here.
Here's the good one, this one doesn't have any hardly.
Yeah, so
Okay,
that's
I want to get back to the half-running joke for this. So we're going to go benchmark.
benchmark, B's benchmark, partial is P, and not met is N.
We're still confused between P and proficient.
But I think that's fine, because then you can identify who you feel really has it. I mean, there's always, even if they have a little bit of blue, that just kind of shows that
So
they have
let's
some
number them,
areas
that
to
way we
tighten
know
up.
which number
Yeah,
needs
so
help.
we can mark
Just number
those.
them quickly.
All right,
Let's let only one person should.
yeah.
So as you number them, pass them out. We'll go like cards as you number them.
And we're going to go, last week we really kind of changed the way we were looking at stuff. We were saying we wanted to run to it. Because before we would give benchmark if there was if the reasoning was good, the pictures, but last week we said we're really going to stick to precision.
Right.
And
Math practice 6, 10 to precision, so.
And so if their answer is correct, but if their explanation is weak, then we're not going to. Then we're going to say they only earn partial.
Yeah,
right?
that's fine.
Is that what we're saying?
Yeah.
I
Okay.
agree.
Thanks. So if the answer is 103 meters, we're saying that's not precise, right?
Square meters.
Yeah.
Is that what we're gonna say?
Yeah,
We're dealing with.
Thanks, I
Yeah.
lost over that one.
okay, because that's real important, because that's what distinguishes between the intranet and perimeter.
And linear, right?
Right. So what we do is we put them in order now, and then we'll go through each paper and see how we all rated them, and then look at the actual work. Okay, student number 1, Peter, what'd you have?
Said not met.
Patrick?
I put partial.
Sherwin?
Not met.
And I put partial. Let's look at that one. Freddie, Sherwin?
Partial.
And I said partial
And at
too.
the time, I counted this correct because it was just the first time they had ever done it, and as long as they got the number correct, but we haven't had any chance to really talk about the meters squared either. So at the time, they came up with the correct solution, but we haven't focused on the precision at that time. But
A good strategy is always remind the students when they see square meters to think in the area of something squares being inside an area. And we always talk about, like when you lay tile on the floor. But so that'd be the difference between, you could see 103, you think right away it could be perimeter. But once you see square meters, it gives you a cue that that's area.
One of the things that Patrick said last week, he stuck with me. I mean, the question specifically says, find the area in square meters.
Yeah.
And so then because I
That's
forgot
something you
what
can
problem it
focus
was
on, right?
last week, but that's the part where you said, well, that's just not precise because the answers they were giving weren't directly tied to the
Yeah.
question.
Well, in some of the previous discussions we've had where in looking at work from other grades was that one thing we're seeing is that they're just not reading thoroughly, and so we want to get our kids to really focus on reading the question, making sense of, just going back to those practices, making sense of the problem, and then really thinking about what is my answer going to tell me? When I find the answer, what is it going to tell me and how is it going to help me respond to what the question
Yeah.
is? So obviously that means understanding what the question is. So we thought that was really important as far as us focusing on it, getting our kids to put that into practice because it is a math practice. So I think when we did that, that's where the whole precision part came in, because if it's right there, if it's really within the question, then we should be able to reasonably expect the kids, hey,
Yeah.
this is what you need to show. So if it says square meters, then we need to be able to put those two things together and put it into our solution.
And then again, area, it's got to have square inches, whatever. It's
so
got
I'm making my not met, partial, and then I'll do my
Okay.
pencil.
And then
Okay.
we just keep in mind that this is really a beginning thing.
Mm-hmm.
You went over with them in the blue, but it's something we want to kind of go back
Yeah,
to
and
and
then I
see.
can show you what we did today to address some of
Awesome.
the things.
And then when she had numbers close, or something, because then my question was like, how did she arrive at it?
79 and 76.
Yeah, how'd she arrive at those two numbers? Because she looked like she was starting, or he was starting to do the right thing, but they ended up with pretty bizarre totals.
I don't know either. That is bizarre. How did they end up with 79 and?
So that's the one that took me a long time. I was
But I
sitting
remember
back
when
trying
she
to.
did this, she was sitting there for the longest time, and I think she just picked, I don't know, random numbers.
And this was
I
the
think
first
she
time
went-
dinner, you said?
7 plus 9,
Okay.
or 79 and 76. See, there's a 7 and a 9 and a 7 and 6, and she looked at the horizontal lines right here to combine 7 and 9, and then she looked at the vertical line and said it's 7 and 6. So she did 79, 76.
But then even if you look in the calculations, though, 70 plus 70,
Yeah.
you turn
She got
into
40.
40. She forgot the one.
Yeah.
So even just the basic concept of
Yeah.
decomposing.
So I'd be
she didn't do.
interested to see what she did in the next round.
If they had just counted, they would have done all right. But they got some kind of.
Yeah, see, I got it backwards. So I think I'd be willing to change that one to a not.
Yeah.
Well, at least they put 7 times 7, they just didn't find the product, and then they put 9 times 6, they didn't put the product, so they started, so
I think what,
I think that's why I put partial, but I go with N.
yeah.
It said 29, I didn't, again, where did they got that?
Yeah, what interests me too is the model itself. it doesn't really reflect. So again, it makes me question whether they understand the area. Like they got the bottom part, you know, they did okay, I got to multiply these, but then they got 29, so there's a lot of,
I think for her, what she ended up doing was she was trying to write this down after I showed them on the exemplar that we're actually doing 7 times 7.
okay.
And then she's like, oh, I forgot, I need to do it with my blue pencil.
Oh.
So this is what she did at the beginning, and she's known to be sneaky like that.
Which essentially is just adding up all those numbers that are there.
Yeah,
So,
that's
Geraldine.
Well, that makes perfect sense then, because I was looking, my question was, how'd she get those numbers? Because her numbers were right, but if you looked at her work, it didn't reflect what she was doing.
Yeah, because she said the playground is 29 meters. I don't even know where she got 29 from.
well, she just added all those numbers that are on there, the 7,
Just
7,
added
9,
them all,
and
yeah.
6.
Yeah.
So that is, at first I thought that was
Yeah.
perimeter, but that's not even perimeter either. She just, which is another issue, right? So definitely, this is where the value comes in looking at it across grades, because that's what we're still dealing with in the upper grades, is trying to get kids to really stop and think about the problem, because rather than just doing random things with the numbers or just going through the operations with the numbers that are in the problem.
Yeah.
So again, just seeing that in third grade, knowing that that's something we want to start addressing.
Okay, student 7, Peter.
I didn't see that one.
I
Okay.
put partial.
Sherwin?
Partial.
And I had partial.
Yeah, goes back to precision. They got
Yeah, just square meters
103.
already.
Yeah. They just need the
Was
square.
them breaking it down, decomposing, was that important? Because they have,
No, I just showed them that that's a strategy when they look at 49 and 54 that they add and decompose it.
okay.
So they haven't been introduced to the standard algorithm yet?
Is that
Not
in
at
third
this
grade
stage.
though?
Fourth grade.
Fourth grade is the third one? Okay.
So they do number lines and decomposing at this point still.
Okay.
Okay, student number 9.
I said partial. I think that's the one that got me thinking. I initially gave benchmark, but because they didn't say square meters.
Wait,
Patrick?
which one?
9?
9?
Yeah, 9.
I put partial also.
And it's, what did you get, Sherwin?
I put benchmark.
I had put, but the only reason is because they don't have square meters
Right
there.
here.
They do have square meters up there, guys. I have benchmark on mine.
You're right, I'm wrong.
I had a benchmark. Student number 10,
I said partial.
I said not on that one.
Sherwin.
I think I said that.
I did partial, but then I'm looking at this now because I'm seeing how they broke down the number and they got 39 and 54 and it should have been 49 and 54. And I don't know where, it looks like they filled in 103 right there.
Yeah, 39
See,
plus
look,
54 on the
39 and
bottom.
54, no, so it should be not
Yeah,
met.
I think that was one that caught my attention too, and I'd want to know, find out more about that student.
Yeah.
Yeah.
I said partial because of the explanation.
Yeah, I
Didn't
did
match.
partial too, and then I just realized they put 39 plus 54,
Good.
Who's that student,
Not that.
Sherwin?
not met.
Okay, they didn't put square meters by, since we're working on precision, it's just
Yeah.
square meters.
I think the other thing I was, and again, it just depends on what we're focusing on, but I really try to get my students to use models as a tool. And so if you look at the model, it doesn't match the problem. If you look at where the 6 meters is, you see how there's like more than, it's not accurate is what I'm saying.
Yeah, there's 8 right
You
here.
counted the squares?
Yeah.
There were a couple of them that
Well, I
I
did look
counted
right
the
to me.
squares.
Counted the squares.
Some of them
Yeah,
squares like
yeah.
13 squares by something.
Yeah, so this is an 8 by 9.
Boy, that's precision.
I didn't
right?
see
So
that.
I guess the point is, again, and I would struggle with that one because it just depends on what our purpose is. And I know right now we're trying to look at, to see that they understand the problem and in doing so, seeing if they are able to get this correct solution. But I
The
guess,
thing that's interesting to me is like, it's hard because you don't have, unless you have a ruler and you spend more time dividing out to get the accurate number. Because I know for a fact that there's no way my lines are gonna be straight.
But still, I think it's important that they get those right number lines because that's the image, that's the representation that's going to nail it for them so they can see, oh, that's why it's 49 squared because there's 49 squares in there. And if they get like they turn a 7 by 9 into a 13 by 6 or something, then they're just not going to get that right image. And I think
Well,
that
then
image is critical.
Wouldn't that be better just to put on graph paper?
That would be.
yeah, but it's still like, I mean, they're not going to have graph paper if they're doing, like, since it's a park practice test.
Okay,
then, you know what I mean? I guess it's just,
Yeah.
again, it's
okay.
somewhat
So
nitpicking,
you guys
but,
want to go partial on that one? I have partial
no,
anyway.
but I also, I had partial, not necessarily because of that,
You
but,
had it for the square
yeah,
meters?
yeah, but because, again, I'm very focused on models, and so.
I didn't realize that
yeah.
either. I just thought, I was like, oh, they drew a model, so they're good to go.
Right,
But then
right,
when
right,
I actually counted them, the rows and the columns, they don't, like, this one doesn't, it's an 8x9 when it's actually a 9x6.
So if we think of it as a tool, maybe it's not for this particular task, but just in general, we want to make sure that if we're going to use models, we want them to use them accurately,
Yeah.
you know?
I
so-
agree.
Unless they just go to an unmarked array. Have you addressed that?
That's what
for
we're working
multiplication
on now.
now? That's what you're starting to get to, yeah. I mean,
But
because
another-
that's perfect, because then you say, like, who wants to draw this many squares?
Yeah,
Yeah.
I could see me trying, if it's going to be precision, I'd spend more time doing that drawing than solving the problem.
They should have seen the kids today, even just with the tiling that they were doing, how precise they wanted to be. And this one, the reason why they went to that was because a problem prior to that was it looked like this.
I see.
So they tried to create their own grids.
Well, that's pretty sharp then. They were using they were learning from the test questions. Because that's a good strategy.
Kids got the wrong
area of
answer.
The playground is 137.
then the more-
I didn't look at the model, but even just the numbers they were adding,
It's
it
all
was a
off.
70 plus 67.
Yeah, I would go with that too.
So you want to go with N or P?
And even if you add 70 plus 67, it's not going to, oh, no, never mind, that's equal 137.
37 rather than.
Yeah, I don't know where they got 70 and 67 from.
But the explanation is solid. And they did write square meters.
Can I just say that real quickly? Because again, it just brings up the previous discussions where I just want to make sure that we're focusing the kids on getting to the mathematics as opposed to,
Yeah,
Just-
they're going to be spending all their time making tiles, making them straight. I would think, I know.
no, but see, again, if we want to raise the level of it, so if you look at the second one, the answer is 103 because I did multiplication. See, that's the kind of stuff that we want to eliminate because it's just fluff. So even though we're considering a benchmark, we definitely want to tighten up the explanations because,
Good part, because they're saying what they did rather
You
than
saw
Right.
why they
that,
did it.
that's
yeah.
They're not telling us why they did it.
So definitely, again, just because we say it's benchmark, we want to make sure that we're still tightening things up
Okay,
because,
so last week I had an interesting eye-opening experience, I guess. And I had to have some dialogue with Lorenzo and Deb regarding this because my notion of math writing is being able to explain the math and what they did rather than being procedural, because that's what I was getting from you guys
Right.
last week was procedural. And I remember having dialogue with Lorenzo and saying it's not about procedural anymore. We're getting more
wait,
onto
you
the,
got that from us last week?
yeah. Because
We were talking the opposite.
because the fluff that I saw from one of the students is exactly what I was teaching them last year, just to explain your because. Why did you get that?
Yeah.
So my because was, the reason why this is the answer is because I multiplied this times this. That's the reason why I got my answer.
Which is procedural.
Yeah, which is procedural, but it doesn't tell us, so why did you multiply these numbers? So the answer.
Which was-
I-
yeah.
So if you said I did it because I had multiplied length times width, and that gives me total square meters, that gets to why you were doing it. But if you just said, I did it because I multiplied 7 times 7, that's the procedure, and that's not telling us why you did what you did.
Okay, so this is where I'm
Is that-
confused.
Sorry.
Can I just say
Sure.
something here? Yeah, you're absolutely right, because if they just say, I got this because I multiplied 7 times 9, that's the procedure. But as you're saying, if I got this because I multiplied the horizontal or at times the vertical and got the area, or if as you said, I multiplied the
Length times width.
yeah, length times width, and I got the area, then then that's conceptual, as opposed to I just multiplied 9 times 7, yeah. Yeah, because then you understand what they're using. And you see there, what do you have there? You have the image, you have the concept, you have the facts are correct, then you have your procedure. And what's the concept? Oh, I'm multiplying length times width,
Yeah.
or the vertical times the horizontal.
So that's what you're saying here, is you would just say I multiply 9 because that's the length of one square
Yes.
and the width times 6. So you're just adding that
Yeah.
length times width in
Yeah.
it. Okay, so now I see
Yeah.
what you're saying is taking it to the next level, okay.
Because when you have, and if they have all of their calculations, which they have on the top, I mean, there's the facts right there and the procedure within the
Yeah.
calculation.
They're just repeating it.
Yeah, so that's where we're, like, with, I guess the writing part of it is really focusing on the mathematics, like why you do something, because even then, you know, that, proving that you know that it's area, you know,
Yeah.
that you have to do those things. And
So the concept would be the
yeah,
length
so
times the
really,
width.
I mean, another thing too is like when kids say, first I did this, then I did this,
Yeah.
and that's what we're trying to get the kids. Now, I mean, granted, that's like 5-6 years ago, that's what we used to teach them.
Yeah,
you know?
we taught
Yeah,
that.
and so now we're really trying to get them just to focus on the
Okay.
mathematics.
Yeah, I see where you
Yeah.
guys are coming from, because actually I was like, this is what, I mean, it looks good to me, so that's why I was kind of like.
So length
I-
times, if they were mentioned length times width.
Yeah,
multiply
okay,
that
so,
would-
awesome.
It may seem like it's not nitpicking, but it may seem like it's just two words. But those two words are the concept of a two-dimensional surface.
Right.
See, that's what you're looking for. So if somebody says, I multiplied width times length times depth times height, now we're talking about a cube, you see?
Right, right.
So that's what you're looking for. That's the image, the concept, the facts, the language, and the procedures all rolled into one little sentence like that.
And see, and it is a difficult thing to grasp even as teachers, so that's what the value comes in these discussions,
Yeah,
is because
definitely.
we get to see that every time, and then we just go back and we refine it. Even though we're looking at your class, we're gonna go back and
Yeah.
we're gonna continue to refine that as well, and it's a process, it really is.
And I like how, you know, like tomorrow, since we're still working on it, I mean, that's something that I can definitely hit on and keep focusing on, you know, because we are going to start looking at length times width, not just looking at, you know, the grids and stuff like that, but, you know, and I'll show you here in a bit after we go through all this. And it just gives me some ideas on what I need to focus in on, fine tune tomorrow too.
So you haven't even introduced the length times width? This is the first time they're doing it? Well, because then I'm thinking, well, I wouldn't, if you haven't introduced it, then how would
It's the
they
first
write it?
lesson,
So,
right? This was your first lesson today?
Yeah,
This
regarding
was just cold, though.
Yeah.
They just did this cold.
wow,
So,
then I'm impressed.
Well,
I want
which
to
is-
back
which is-
up what I
which-
want to say then.
Yeah.
If you never introduced that, if that's never been instructed, then I'm impressed with what they did. Still, what they wrote.
yeah, yeah. No, but it gives us something, and it gives you something to build on, right?
Yeah.
Because pointing that out, saying, look, you know, you were able to do this, now let's take it to the next
Yeah.
level, let's refine this, because, yeah, if you gave this to them cold, then it puts it in a different light. I mean, I still think
I
we
mean,
need to
we
go
looked at
through.
arrays, we looked at, you know, the problems previously to this, but then that was it. Like they don't really know much about 7 times 7 or length times width in general yet.
But then as you did arrays, I mean, didn't you just, you had to give some wording to those two different dimensions. What wording? If it
The
wasn't like
height and
the,
I don't remember.
the two axis, I mean, you could say the Y, the X, I mean, there's.
No,
the two-
I think I said length times width, but it was like probably back in October is when we did it, so it's been
You
a
probably
while.
said this side times this side.
Yeah, probably. I'm pretty sure.
That's what
Or
I
it-
would've said.
yeah.
The two sides, you multiply the two sides together or something like that. But I mean, you know,
So then it really gives you something to go on, especially in instruction, right?
Mm-hmm.
So you know something that you can connect to that they've already known. They've kind of shown that they have, you know, they are bringing something
Yeah.
to it. So when you actually specifically, like you've done already, you know, done a lesson on this, then it'd be interesting to see the results from
Yeah.
that.
And this was the first time they've seen it. That's awesome. Okay, Sherman, what do you pick up from all of this? What'd you pick up?
so in talking with Deb and Mia when we had our meeting last week, we looked at these and, you know, after breaking the park assessment, and we looked at the different areas that the students were being tested on, and we realized that there's a lot of aerial problems. Not too many, but there's quite a bit of, like, there's a handful. And we noticed that there's a progression from something like, let's see, they actually did it further, right here. So they can actually see the grid it's drawn for them, and they had to figure out what the area of, or the, one of these that is 24 square units, so that to look at this. So we realized that this is more of an entry problem, so they had to go from this to what we were just looking at now. So what we decided was that, they need to have a better understanding of what a square unit is. So then today, what I did was we looked at problems where we used tiles, and this is what I came up with the worksheet, so they had to use. And based on the concept that Lorenzo wanted us to focus on as a 5, what is it called, practices. So they use 6 tiles, and, I talked about how each tile is a square inch. It's an inch this side, it's an inch on this side, so that's your square. So then they had to figure out what the square units of each one of these is, and then I had them share, what strategy they use, and all of them got it right except for one group, what they ended up doing, which was pretty interesting. So they obviously drew their tiles like this, and then this one group, the misconception was they counted the lines in the box here, rather than the square units. And I didn't tell them anything. I just said, here's your square units, figure out what your answer is. And I wanted just to talk and work together on it. The rest of them were able to see, okay, there's 4 squares here, 6 right here, and I think this is like 8 and 10 and 14 or something like that. So the rest of them were able to figure it out, but this one group actually counted each line like this, 4, and another 4, another 4, and a 4, and they got 16. So that was something that we...
I'd be real careful. I wouldn't introduce inches squared, because at 2nd grade, I haven't put square inches right there, or SQ inch.
Squin, we called it squin last year,
Yeah,
but I don't know.
square inch, I would put that in 2nd grade. Because we had a big discussion over that, because I know, remember, Peter, it was 4 square meters, like 4 to the 2nd power, the confusion there. But even here in 2nd grade, they don't understand. I would think, I would write down square inches myself.
So what I did on the board was I just put this is the same as square inches, is what, so the kids can look at it like that. So I don't know if, I thought that even just something like this for them to kind of put 2 and 2 together, but I don't mind.
It might be, because to me, like, the whole concept of area is square units. That's the whole concept. And for them, so you drill them, you make sure they write it 1,000 times, square inches, square meters,
I
square.
guess the question
whatever.
is, do they see anything like that at that level?
Just this one right here, that
Type
one problem,
assessment.
this one. So what I actually ultimately...
But written this way is what.
Oh, I don't know. I'm not too sure. Because I don't know if they would expect them to do 6m squared. I wasn't too sure about that. Or just address it like the words of a square meters.
See how they write it out.
Yeah, so that's definitely something worth thinking about, because, yeah, I mean, if writing it out as even just SQIN square inches focuses them on that idea of it being
Which is the
square.
concept there.
I mean, do you deal with exponents at all, 3rd grade? See,
See,
so,
that's an exponent.
Yeah.
And even there.
because eventually, right, you can transition.
Once you understand what a square
Yeah,
inch is.
yeah, that this is another, because, I mean, in 6th grade, I'm always having to do that, like, it's seeing 3 different ways, this is the way you're gonna see it, and you kinda gotta know all of them, but by that point, they've had experience with at least 2 of them, so I'm introducing a 3rd way that they're gonna see it.
Yeah, it's just
Yeah.
like exponents, anytime I see an exponent, I think, it's like 2nd to the 3rd power, 4th, it's something to that 2nd to the 4th
Mm-hmm.
power. So to me, it caused confusion. I know we had that big old discussion. And, like I know in 5th grade, we said, hey, meter square would be fine, but in 2nd grade, I would put, square inches, square unit, whatever it is.
That's
But
fine.
in 5th, we agreed, whatever unit squared would work.
So, yeah, I can change it up. I mean, because I wasn't too sure too how to approach this, and I wasn't too sure if that's what they would expect.
It's a beautiful worksheet. I would just not put exponents myself.
So they were able to use tiles though when they
Yeah.
did that, and they just drew the line.
So basically, when the kids came up to present, the first group that had the misconception presented first, and then the next group that talked about how they just counted the tiles, how they drew them out and tied, and then the 3rd group actually kind of did like what was interesting right here is they put 5 tiles here and noticed that there was, this shape was the same on that side, so it's just kind of like flipped, is what they were saying. And then the last group, actually, because I was challenging them, what's another way, if you didn't have tiles, what would you do? And then the first girl said, well, here's 2 tiles here, and here's another 2. 2 plus 2 is 4. Here's 3 tiles here, another 3. 3 plus 3 is 6. And so they're doing that, and I said, well, what about, if there's another operation that you could possibly use? And then one of my students said, well, I know, this right here is a 2 and 2, because there's 2 right here and 2 this way, so 2 times 2 is 4, and 3 times 2 is 6. So that's as far as they got. So tomorrow, what I actually want them to do is, look at length times width and how it relates to the number of tiles that we saw inside of these. And then I actually want to take a blue colored pencil and create 2 rectangles within that shape. Because last year, we did have a practice problem that was like this, in the SBAs, where it's like, so-and-so built a porch with these dimensions, and they want to add a porch to this. How much is the area now with the porch and the house, or something like that? So then they had to divide the 2 rectangles and figure out the length times width on the 2 rectangles, and came up with a solution.
They can probably discover a formula just by looking at the squares, I would think. When you 2 and 2, and you go, if this is 2 this way and this is that way, and you got that many squares, but what's an easy way of doing that?
Yeah, so that's the learning goal tomorrow, is to be able to relate what we did today by tiling to doing length times width multiplication.
Which actually brings me back to Mr. Cardenas's suggestion that if we, it doesn't seem like a big deal, but if we say square inches, and with what you're doing here, I think that ties in more with that concept, with that idea of area, that when we're trying to find out what the area of this space is, and then bringing in one of those types of questions that you just mentioned, I think it gets them to focus on, okay, right, I'm dealing with this space inside here. So again, it seems like a little thing, but I think it probably lends itself a little bit better, and then later on we can introduce, they'll see exponents.
Yeah, okay. And I don't mind crossing this out tomorrow and say, we'll write square inch here. After all the other groups presented, I went around, so what did you get for number 1? They're like 4, 4, 4, 4. And then, at the end, we talked about that. And then when I showed them that, what they did was they counted up all the sides, but we're not looking at the sides of the squares. We're just looking at the square inch that we saw. How many squares did we use to create this, or to cover that whole space? I said 4 exactly, so that's why some of them numbered the number of squares that they use to cover up that space.
Awesome. Anything else?
And then, so once we get to this, and then what I'll do is have them do this again and see what the end result is, and see if what their understanding of area is by Thursday.
Okay, do you have any closing comments, Patrick?
I think these types of activities are definitely what they need. Again, just looking at something like this, really just reinforcing that each one of these is a square inch. You know what I mean? Like, because as we're talking about area, just trying to reinforce those things as you talk about it, and as you're just kind of observing as they work. Something to look ahead, maybe, especially getting into, do you guys deal with the formula at 3rd grade? Not at all? Okay. So then, because, really what all we're doing in the upper grades is we're trying to find more efficient ways. So just so you know, like what comes ahead. So as long as they have this, it's almost like we can transition. If they're strong in this, we definitely can transition. So like, how do we find the area of the basketball court? So what's a more efficient way? How do we figure out, are there ways to figure these things out without having to put down tiles every time? But, that comes later, but definitely, just reinforce some of the key foundational things with areas.
Peter, any closing comments?
I'm impressed that they got this. What I'm impressed by is that you did 2 regular shapes and you went to 3 irregular shapes right away. Because I think that would, because if you're getting to the formula here, it'd be like 2 times 2 or 3 times 2 or something like that. Then, I mean, if they can come up with something like this, this is going to be a 2 times 4, then we're going to have to also add the 2 times 1 down here or something like that. I think that's impressive. I might have done some more regular shapes initially.
I was gonna do that, but I thought with what was expected from this article I read, I wanted them to have more of a dialogue for them to be able to problem solve. What's gonna work for us to try to figure this out. And I think that when I address this tomorrow, I'm gonna focus more on the 2 regular shapes and break it down a little more, that I see more rectangles and those irregular shapes there.
Well, it'd be interesting to hear the dialogue and then jump from here to here. Oh, so if we're going length times width or X times Y or whatever, two dimension shapes you want to, whatever labels you want to give them. And then, so how can you apply what you see here in number 2 and number 1 to number 3? I think that, I mean, that would definitely generate some dialogue in your class, and I think that would definitely be worth listening to.
You've identified who needs help. So that's important. Yeah, it's a real interesting lesson. Awesome. Good job.
So what did you gather from, so are you gathering more from the interaction with the 4th grade teacher and the 6th grade teacher this time than you did with the K2?
Yes, most definitely, because these are, as Freddie was saying, these are concepts that are building up to what the upper elementary students are working toward right now. And I think if this was similar to, or if I presented this to the K1-2, they would have focused more on the manipulatives and tiling rather than the length times width on what they're getting to at the upper grades.
Yeah.
So they're focused more on, the manipulatives and the process of getting the area rather than jumping from that to the next level, which is finding the length times the width.
So what was the most significant thing you got out of it today?
Today, just the concept of emphasizing the length times width in my writing. And I think that's where I was like, oh, okay, that's my aha moment. It wasn't more procedural that they were focusing on last week. It was more, what is a concept that they should include in their writing? Now I see what they were referring to as fluff.
Yeah.
And I think that if they can identify why they multiplied the 7th, rather than just saying, I multiplied these two numbers. So I think that was what was valuable for me today.
Yeah, so you can actually see that, I'm combining, so this is 2 rows times 2 columns in this case, or 2 rows times 5 columns when you're working with this. Or as I said, width times length, or length times width. Yeah. Okay.
And remember, the critical part about area is the square units.
Yeah,
That's critical.
I think
Yeah.
maybe the other thing.
Yeah,
Because they
very
haven't been
critical.
introduced to
The
this.
exponent.
Yeah, to square units rather than inches squared, as they say there.
Well, we compromised with them with unit square, but when I taught 6th grade, I always made sure they put the square, because it's important, because when you write it down, it does something to your brain. Whereas
Yeah.
when you put a meter squared or unit squared, it doesn't really, you forget.
Maybe it doesn't register.
I don't think it does. Not with 6th graders or 5th graders. You still have to drill them on that stuff so they get used to square meters, square units, square units.
So Freddie, you guys are running this PLC now. You ran it with MSA, Zach before. So now you guys are running this thing on a weekly basis. So do you run two, K2 and then 3, 4, 5, 6? Is that what you're doing now?
We're doing K1, 2, and then 4, 5, 6,
Okay.
two on Tuesdays. What was happening is Zach, we're trying to utilize Zach as much as we could. So Zach's been training the teachers, like he works 2 hours with each teacher. So when he comes, that takes up his whole day. So he's not here. But now I'm working it, because we need to
Yeah.
do PLCs on math
Yeah.
every week, sure one. And the funny thing is, the teachers, the 4th, 5th, and 6th, we gotta do them every week, Freddie, because every other week's good, but we gotta do them every week.
Oh, so they themselves.
Yeah, because they
ask for
wanted the consistency.
So I saw a lot of good feedback here, so they're exchanging ideas there. That's what's happening. That's the power of the PLC as I see it. They're exchanging ideas here, aren't they? Yeah.
And they work as a team.
Yeah, I saw.
They
that,
really
yeah.
do. Teaching's a lonely profession. So we were trying to get away from that.
Especially in this country.